3.5, finding trig ratio from a point. So now we're doing right triangle trigonometry on a coordinate plane. It says angle theta is in standard position and the point 5, -7 is on the terminal side of that angle. What is the exact value of cosine of theta in simplest form with a rational denominator? So my first job would be to plot the point 5, -7. Remember, we go right 5, down 7, make a point. Then what I want you to do is make a straight line going from the origin to that point. That is the terminal side of the ray, so we don't know whether this angle opened up this way or went clockwise this way, and it doesn't matter. What we do need to do is make a right triangle with the x-axis, so you're always coming from the x-axis to your point that they give you. And then so my right angle would be right here. And then our angle, when we're doing theta, the angle they're talking about is the reference angle, which we talked about was always formed with the x-axis. So it's always going to be here, 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 or here. It's never going to be with the y. So we're trying to find cosine. Well, cosine is ka, or remember, sometimes I would write it like this. It's the ratio of the adjacent leg of the triangle over its hypotenuse. So let's label what we've got here. Since 5 is an x value, that means this leg is a length of 5. -7 would be this length. And so what do I need? I need adjacent, I need hypotenuse. I don't have the hypotenuse right now, so I would have to find it using Pythagorean theorem. So I would have one leg squared is 5 squared, plus the other leg squared is a negative, which will turn into a positive once I square it, equals x squared. So that would be what, 74? Okay, I would try to square root both sides. I don't know if a perfect square is in that. 74 divided by 16, no. 4, no. 36 would be no, because that would be, what, 62? No. So there's nothing I can do here. I'm just getting that the hypotenuse is the square root of 74. And now I can set up my cosine ratio so that I have the adjacent leg to this angle would be the 5. So I would put 5 over my hypotenuse, which I found to be square root of 74. But it says with a rational denominator. Well, non-perfect squares are irrational numbers because their decimals don't ever stop or repeat. So we would have to rationalize the denominator. So multiply by square root of 74 over square root of 74. Multiply straight across to get 5 square roots of 74 over just a normal 74. And that can't simplify, so that would be your answer. All right, number 2, we've got a new angle, and there's a point at -5, -5. So we're going to go left and down, make that connect from the origin. So this is a ray. We don't know if it opened counterclockwise or clockwise, it doesn't matter. What we need to do is make this a right triangle with the x-axis. So I'm going to drop down and make a 90 here. Here is my triangle with theta right here, formed with my ray and the x-axis. And so let's label. This went back 5, so this would be a distance of -5, and this went down 5. So the only part I don't have is the hypotenuse, and they're wanting me to find cosecant. Cosecant is the reciprocal of sine. So instead of having where sine is opposite over hypotenuse, cosecant of an angle will be the hypotenuse over the opposite. Okay, so I'll have my hypotenuse is what I've got to find. I'll do Pythagorean theorem. Be 25 plus 25 will be 50. Square rooting 50, there's a perfect square of 25 in that. and square root of 25 is 5 square roots of 2. And now I can make my ratio. So hypotenuse in this problem is going to be my 5 square roots of 2 over the opposite, which is the negative 5. You have to include that negative, it's very important. And then I see a 5 divided by 5, that's really a 1. And so that is a positive divided by a negative, so it would be a negative 1 square roots of 2, or just negative square root of 2. So I want you to see if you notice anything. Any patterns between what the word pair is and then the trig ratio. Well, if I have my angle here, the opposite to that angle is always going to be the height of the triangle. Doesn't matter which quadrant it's in. It's either here, it's going to be here, or here, but it's always the height, and height deals with the y value. And so when we say opposite, it's always going to be the y. The radius is always going to be the slanted line, and that's the hypotenuse. So instead of hypotenuse, you're really finding the radius of this would be a circle. And so they're going to say r. And then the other leg that is adjacent or next to the angle is going to be the length, or the x value, either left or right. So then they're going to say instead of adjacent, it's x. So sometimes memorizing these ratios will make it easier than having to draw a picture, but it's totally up to you. It's like on number 3, there's no graph. So I'll show you what's happening. If theta is an angle in standard position and its terminal side passes through this point, where this is the x, this is the y, find the exact value of secant of theta in simplest radical form. So I would look up here and say, okay, secant. Secant is the reciprocal of cosine. Cosine is x over r, so now it's going to be r over x. The radius was always the hypotenuse. And so that requires Pythagorean theorem to find. X and y are your legs. So I could just say, okay, negative 6 squared plus 1 squared equals some radius squared. That'd be 36 plus 1, 37 square root. So the radius is the square root of 37. And your radius will always be positive, not only because this is talking about a circle, and so we can't have a negative radius, but also because you're using Pythagorean theorem, which squares negative numbers and always makes them positive. And so this is our r, this is our x, this is our y. We just need our r value over our x value. So I would put square root of 37 over negative 6. And you could flip the negative up if you like that better. There's no simplifying, we don't have a radical in the denominator, so we would be done. So that can save you some time memorizing these ratios.